Good morning, class. This is Mr. Peralt, and in this video, we're going to talk about separation techniques. Last time, we talked about mixtures, and mixtures that contain, well, two or more different substances physically combined. They can be in the form of homogeneous or heterogeneous. And in this lesson, we're going to discuss the different ways in which you can, well, separate those substances out. This is a pretty good little summary slide, kind of showing you the 7 different ways in which you can, well, separate everything from magnetics to remove magnetic materials through filtration, decant, evaporation, or crystallization, chromatography, and lastly, distillation. So let's take a look at a couple of these. I'll probably skip over magnetic, which, of course, if you have any metals, you can certainly remove those by, well, magnetism. But let's take a look at some of these other separation techniques that you might be less familiar with. So the first one up is to decant. Probably the best way to describe a decant is that it is a very careful pour. So you might have made something like macaroni and cheese, and you might be unable to find a strainer or a colander, so you might kind of carefully pour the liquid out, preserving the noodles behind. That would be called a decant. And in this image, we have a beaker with a solid material here at the bottom, and they're carefully pouring off the liquid. Our next separation technique is probably the most important one, which is a filtration. So filtration uses filter paper to separate the solid material from a liquid. And in this image here, we have a funnel with a piece of filter paper. We have these blue little particles that are being trapped inside that filter paper as the kind of purple liquid passes through. Okay, so filter paper is porous. It has holes in it. So it allows the solid material to get trapped on one side of the filter paper, and it allows the liquid portion to pass through. Okay, so again, a very common everyday example of this would be a coffee maker. Okay, other examples of separations are things like chromatography. Chromatography is based on movement of particles. So you have a mixture, and the particles will physically move along a mobile and stationary medium. And the faster moving particles will sort of outrun the slower moving particles. So, kind of the best way to think of chromatography is a race. So that the particles are literally moving or racing each other, where faster moving particles will, well, separate themselves from the slower moving particles. This does relate to the mass of particles. Heavier particles move a little slower. The lighter particles, the ones with less mass, they travel, well, the fastest. Some examples of chromatography that you might see in kind of an everyday environment, things like tie dye. So you could separate colors or paints, pigments, and again, certain colors will travel faster than others. Another kind of everyday example of chromatography is in the form of DNA testing. So in this particular example, here we have a paternity test, and you'll see that some genetic material for the child, who is in the middle part, matches that of mom, whereas other genetic material and genes will match the father. Of course, this can be used in other things like crime scene investigation and things like that, but this is just something that people are just usually kind of familiar with. Other forms of separation are things like distillation. So distillation is a rather simple process where you take a solution. So here we have some sort of mixture, a liquid with a solid dissolved in it, and you essentially heat it up and you boil off some of that water. The water travels up and down what is known as a condenser. So a condenser is where the hot gases are converted back into the liquid state. So when it comes out the other side of the condenser, you should have essentially pure liquid or pure water left over. We'll take a look. Here's another one. Here we have some salt water. So again, the water is boiled off and collected on the other side of the condenser, leaving the salt behind. The most famous practice of this is probably the production of moonshine, where alcohols are boiled off and separated according to their boiling points. Okay, but in this particular case, we have what's known as a still. A still stands for distilled